first off, grades are updated in Infinite Campus as of this morning, so if you're curious where your current standing is, take a look at Infinite Campus. Hopefully everybody's continuously watching Canvas for their grades there too. This is the last week of the quarter. My grades are going in on Wednesday because I will be gone Thursday, Friday, Monday. And I have to get grades in for the quarter before I get back. So any retakes or anything that you're planning to do to get your grade up for the quarterly grade needs to be done by Wednesday, not after school. Wednesday after school I'll be getting grades in, so I don't want kids coming and taking quizzes and I have to stay here till 7 to grade them and get grades in. So if you want to retake things, it needs to happen after school today, before school tomorrow, before school Wednesday, or interventions tomorrow or Wednesday. Okay. Okay, this is the last section of the chapter. And it's kind of bringing everything we've been doing in this chapter together. We will have a quiz over 3.4 and 3.5 tomorrow. Wednesday, I'll be reviewing. So I'm going to pass out the review for extra credit tomorrow as well. You guys can work on that tomorrow night. Bring that to class Wednesday if you want 10% extra credit on the test. I'll go through that review on Wednesday. Okay, and then you guys will take the chapter test on Thursday. Friday is a shortened day. We have 5th through 9th periods on Friday. Mrs. Fennell will be my sub Thursday, Friday, Monday. And I'll probably just find a Kahoot or something for you guys on Friday because I don't want to start a new chapter with her on Friday with a short class period. But we will start a new chapter on Monday, even though I won't be here. There'll still be textbook check and that kind of thing. All right? Okay, so there are kind of four concepts in this chapter. First, we learn the distance formula. And if I have 2 points, I'm just going to pick 2 points. 2, 4, and 2, 3, 4, 7, 2, 4, 7. If we have 2 points, okay, you can memorize the distance formula if you want to, which is fine, just kind of like the slope formula. I showed you how to do the triangle method for slope, but I also said you can memorize the formula y2 minus y1, x2 minus x1. Who has seen the Pythagorean theorem before? Got one. I don't know. Let's make this 3. No one knows if it's a right triangle how to find sides of the triangle using Pythagorean theorem. It's this. 3 squared, yeah. It's a squared plus b squared, which are the sides of the triangle, equals c squared. Okay, this is how the distance formula was derived. Okay, so if I've got 2, 4, and 7, 7, and I'm trying to find the distance between them, well, the distance from 2 to 7 is 5. The distance from 4 to 7 is 3. So to find the distance of the hypotenuse, which is the side opposite the 90-degree angle, is 5 squared plus 3 squared equals, call it x squared. So this is 25 plus 9. And then you just take the square root of both sides. And it's the square root of 34. Just square A, square B, add them together, take the square root. Okay? Or you can memorize the distance formula. The distance formula says x1 minus x2 squared. Okay. I must have hit the plus y1 minus y2 squared equals the distance. And it's actually the square root of this whole thing. That's the distance formula. Okay, so if I put x1 in, x1 is 5. x1 is not 5. x1 is 2. x2 is 7. y1 is 4, y2 is 7, and I take the square root of all that. So what's 2 minus 7? Negative 5. What's negative 5 squared? 25, positive. What's 4 minus 7? Negative 3. What's 3 squared? 9. And 35 plus 9 is, or 25 plus 9 is 34. Same thing I got here. Okay. This process, using Pythagorean theorem, is how the equation for the distance formula was derived. So if you don't remember the distance formula, remember Pythagorean theorem. A squared plus b squared equals c squared. Okay. Either way, though, you're going to have to do problems to find the distance. Okay. So if you're struggling with the distance formula, go to Khan Academy, go to CK12, and just do distance formula. I've got some, I think, on CK12 already, but there's others. Do extra practice, whatever you need to get really good at the distance formula, because you need to know it. Okay, not just here, but you need to know it for the ACT. You're going to have, and they don't give you the formula on the ACT. Okay, so that's going to be an easy ACT question, not one of the hard ones. Easy ones come in like the first 10 to 20 questions. You don't want to miss an easy one because you don't know the distance formula. Okay, so we're going to use the distance formula in the rest of this section. We're going to use it in 3 ways. First, we're going to be able to find the distance from a point to a line. Okay? And the thing you need to know about finding the distance from a point to a line is the shortest distance from a point to a line. Let me just do a point and a line. So I have this line that starts at negative 2, goes up 1 and over 3, something like that. And I'm looking at the point 1, 5. And I want to know the distance from that point to the line. Well, I can draw a line from this point to this line in the infinite number of ways. I could draw it here, I could draw it here, I could draw it here, I could draw it. There's an infinite number of lines that will connect that point to the line I'm talking about. But the shortest distance from a point to a line is the perpendicular distance. The shortest distance from a point to a line is the perpendicular distance, whatever that is. If I can find this point, and I know this point, I've now got 2 points I can calculate this distance. Okay, so this is how it works. You're given a point, and you're given the equation of a line, and you're trying to find the shortest distance. Well, the first thing you have to realize, this line that I'm looking for has what slope? It's negative. Who can tell me the exact slope? What's that? Negative 1 over 3? That's a line parallel to this line. I'm looking for one that's perpendicular. Because these 2 lines are perpendicular. Everybody see that? So if I know the slope of this one's 1/3, what's the slope of this one? This is from yesterday or last week's. Opposite reciprocal. Negative 3. And if I'm going to write my equation, I don't know my y-intercept. And I'm trying to find the equation of this line. Because if I know the equation of this line, I can figure out what this point is. And once I know this point, I can find the distance between them using the distance formula. So first off, you need to find the equation of the line. I know the slope, but to find the y-intercept, I'm going to plug in, because this point that I was given, 1, 5, is on that line. So I'm going to plug 1, 5 in. To solve for b. 5 equals negative 3 plus b. So b equals 8. Okay, so now I have the equation of this line, and I have the equation of this line. I want to find this point where they intersect. Okay, I can either graph it really, really precise with a ruler, and then hopefully they intersect at an integer point, or to figure out where they intersect, I just set these two equations equal to each other. Because does everybody see that the y value of this point is the same for both equations? The y value here, whatever this point is going to be the same for both equations. So if I set this value of y equal to this value of y and solve for x, I can find what x is at that point. 1/3 x minus 2 equals negative 3x plus 8. Now I'm just going to solve for x. I'm going to add 2 and add 3. So what is that? 10/3 equals 10. Multiply by the reciprocal. Okay, so the x value where these two intersect is actually the point 3. 3 comma something. How can I figure out the y value? Plug x in to either one of those equations. It doesn't matter because it should be the same answer. So I'm going to plug x in. I'll plug it in over here. I'll just plug it in here. 1/3 times 3 is 1, minus 2 is negative 1. So this point where it intersects is 3, negative 1. Pretty close on my graph, but not exact. This is why trying to graph with precision, if you want to use the graph to find that point, is really important. Use a ruler. I just slapped a line through 2 points, and it was close, but algebraically I proved that that point where they intersect is the point 3 comma negative 1. And I did that by setting the two equations equal to each other. Okay? So now I know this point, and I know this point, because I was given this point. And I'm trying to find this distance. That was the problem. Find the equation, or find the distance from this point to this line. That's what the question asked me to do. Okay, how do I find the distance between 2 points? Distance formula. Okay, if you can't remember it, draw a triangle. Okay, this distance down here is 6 units. The distance over is 2 units. So I square this, I add it to the square of that, and I take the square root of it. 36 plus 4 is 40. So the distance must be square root of 40. That's the answer. Okay, I told you, I think Friday, this section that we're in right now is the hardest section of the chapter, because all of the stuff that you're learning about finding the parallel slope and perpendicular slope and finding equations of lines that we did Friday is all coming into this process here to find the distance between two lines, or from a point to a line. Okay, so we've covered 2 of the 4 things in this section. We've covered the distance formula, and we've covered finding the distance from a point to a line. If you are still struggling when it comes to the homework, watch this video again. See how I do it. Okay. Next, we're going to find the distance between 2 parallel lines. Everybody agree these 2 lines are parallel? Why? Slopes are the same. Good. Okay, so if they're parallel, they have the same slope, different y-intercepts. So if I just do a quick graph to see what they're asking here. Here's plus 4. And there is 1. And they are parallel. Okay, same thing here. To find the shortest distance between 2 parallel lines, the shortest distance is the perpendicular distance. Okay, so if I'm trying to find the perpendicular distance, I'm going to pick a point. I'm not given a point in this example. I'm just given 2 lines. I'm going to pick a point. And the point I'm going to pick is a y-intercept, because I think dealing with the y-intercept is a lot easier than any other point. I can pick the y-intercept here or the y-intercept here. It doesn't matter. Everybody understand what the y-intercept is, where it crosses the y-axis? Okay, so I'm just going to pick this one. I'm just going to sketch in a perpendicular. And what I'm trying to do is find the distance from this point to the intersection here. Well, the slope here is 2. The slope of a perpendicular then is what? Negative 1/2. Okay? I could algebraically try and figure out where it connects here, or I could start at the y-intercept. I know it's negative 1/2, so I'm going to go down 1 and over 2. Where it intersects this line is the point 2, 3. I just used the perpendicular slope to get there. It saves a lot of math. Okay, so now I have my 2 points. This point is 4, 0, sorry. 0, 4, let's get it right. The y-intercept. And the point it intersects is at 2, 3, and I just used the slope to get to that point. Now I just need to find the distance between them using either the distance formula or using what you know about Pythagorean theorem. The distance from in the x direction is 2 units, so I have 2 squared, and the distance in the y is 1, and I take the square root. That way is a lot easier to me than memorizing the formula and plugging in values. Just taking the difference between the x's, square it, the distance between the y's, square it, and the square root of that number. Okay? So 4 plus 1 is 5. The shortest distance between these 2 parallel lines is the square root of 5 units. Again, go back and watch this video when you get to finding the distance between 2 parallel lines if you don't remember the process. The textbook also lays out the process, and there's also videos in the textbook if you haven't watched those. Okay, and the last point here in the section is finding the equation of a perpendicular bisector. So if I give you 2 points, negative 1, 2, 4, 6, 8, 2, 4, 5, 2. Okay, I have these 2 points, and I want you to tell me the equation of the perpendicular bisector. Well, you have to know what the perpendicular bisector means. Who knows what a perpendicular bisector is? Okay, so it's perpendicular to this line, and it's going to go through, it's going to be a bisector. So what does the bisector part tell you? Yeah. So the point that I'm going to go through is the midpoint of this segment. Okay, how do I find the midpoint of between 2 points? Anybody know? Remember? Midpoint formula, which is?
I think it's x1 plus x2 divided by 2.
Yep. And y1 plus y2 divided by 2. I always think of it as the average. How to find the average? You take whatever numbers you're looking for and divide it by that number. I always think of it as the average of the x's, the average of the y's. That's, rather than memorize the formula, that's really what it is. So if I add negative 1 and 5, what do I get? 4 divided by 2, 2. And if I add 8 and 2 and divide it by 2, my midpoint should be at 2, 5. Pretty close to my drawing. Okay, and I'm trying to find the equation of the perpendicular bisector. So it's going to be a line. I've got to find the equation of a line. It's perpendicular to this line. Well, what's the slope of this line? 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Goes down 6 over 6. What's that slope? Negative 1, right? It went down, which is negative, and then positive 1, so it's negative 1. Slope's negative 1. So if I want to find the perpendicular bisector, what's the slope of the line that's going to be perpendicular to this one? Positive 1, opposite inverse. The inverse of 1 is just 1. Okay, so I know the slope is going to be 1. I need to find b. I can do it one of 2 ways. I can go ahead and plug in this, because the line has got to go through the midpoint. to be the bisector. So I'm going to plug in the midpoint into x and y and solve. And I have my equation. Or I can just use the slope of 1. I'm going to go to try and find where it crosses here. If I go down 1 over 1, down 1 over 1, I can see it's going to be at y equals, the y-intercept is 3, which is what I found algebraically. So you can either use the slope to try and find it if it's an integer, or you're going to have to plug in the midpoint that you found using the midpoint formula in there. Okay, a lot of stuff in this section. Knowing how to find the distance between 2 points, knowing how to find the shortest distance from a point to a line, understanding it's the perpendicular distance, knowing how to find the distance between 2 parallel lines, and knowing how to find the equation of the perpendicular bisector. Okay, a lot of stuff. So again, if you are struggling doing your homework, come back and watch this video. I'll post it onto Canvas recordings. All right? Okay. Go ahead and do CK12 and big ideas.